What's up, my chemistry people? Today I'm going to teach you about double replacement reactions, okay? And basically, I'm going to teach it like I'm going over this worksheet that is your assignment. So watching this video would be smart, okay? Now, first thing, double replacement reactions. We're going to have to predict them. We're going to predict if something's going to happen, and if something is going to happen, what is going to happen. Now, double replacement reactions only occur if they produce water, a gas, or a precipitate. And you may be saying to yourself, what is a precipitate? Well, I will tell you what a precipitate is. A precipitate is something that is insoluble in water. Okay? And PPT, that's our little abbreviation for precipitate. Let's think about sodium chloride. If I had some sodium chloride and I dropped it into the water, it would separate into sodium positive and chlorine negative atoms. It would dissolve. Since it is dissolved, we would call this sodium chlorine in the water aqueous. Aqueous things in water are invisible, but things that are called precipitates, you can see them, okay? So sodium chloride is not a precipitate. You know, if you put salt in water, it disappears, okay? So let's think of how we would be able to tell if something was insoluble in water. Insoluble means like not dissolvable. How's that? How could we predict if something was insoluble? Well, check this out. You can just look on page 6 of your tables. Like here's your little book, blah, 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 blah. Page 6. Look up here at the top. Up here at the top are the solubility rules, and you have two sections, things that are soluble and things that are insoluble. Now you have to be careful when you're reading this because there are exceptions built in. See, except, right? There are exceptions, so you need to be really careful when you read it. Let's talk about how would we use the solubility rules, okay? I'm going to write down some chemicals here. How about calcium chloride, calcium carbonate, silver nitrate, and silver chloride. Now, we're going to see if these are going to be soluble or insoluble. Let's look up calcium chloride first. I'm looking, look right here. All chlorides, bromides, and iodides except silver, lead, and mercury are soluble. So calcium chloride would be soluble. You would not see that in the water. It would dissolve and disappear. What about next, calcium carbonate? Looking around, I see the word carbonates right here. All carbonates and phosphates, except for group 1 and ammonium, are insoluble. So guess what? Calcium's in group 2. It is not the exception, so calcium carbonate is insoluble. It would be a precipitate in water. If you made some calcium carbonate, it would end up being a precipitate, okay? It would end up being something that was insoluble, all right? Silver nitrate. Let's see if it is soluble or insoluble. Look at the first bullet point. All nitrates, acetates, ammonium, and group 1 salts are soluble. So all nitrates are soluble. So silver nitrate is soluble. The last one, silver chloride. Well, we remember our chlorides are right here in our solubility rules under soluble. All chlorides, bromides, and iodides, except silver. Except silver. So silver is not soluble. So silver is insoluble. Okay? That's how, now the first section of your worksheet, or the first thing you really need to understand about this chapter, is how to read the solubility rules. So that's how you do this first section right here. So now you should know how to do that. Maybe stop the video and do that section right now. Okay? The next thing, let's talk about what happens in double replacement reactions. The first double replacement reactions we're going to work with are going to be just written out with words, okay? So now you're not going to have to worry about writing the formula correctly. These are written out as words. Now this is a classic one that I like to do a lot. Sodium hydroxide plus calcium chloride. If they underwent a double replacement reaction, then sodium, okay, will now be with chloride. So it would make sodium chloride plus, and let's see, now the calcium would be with the hydroxide plus calcium hydroxide. Okay, so the second section of your worksheet is just saying, hey, take these and put them with new partners, okay? And it says highlight the precipitate if there is one. So now, here are the things that we made. Let's see if either one of these things, this is what we started. These are our reactants, and then here's the arrow. And I had to continue it down here because I wrote too large on there, okay? And here are our products. So let's see if either one of these products is going to be a precipitate. In other words, let's see if either one of these is going to be insoluble. Again, we're going to look on page 6 up here at the top. Sodium chloride, all chlorides except lead. So all sodium chloride is going to be aqueous. So that is not going to be the precipitate. Aqueous means you won't see it in the water again. Let's look up calcium hydroxide. Ooh, under insoluble, all hydroxides are insoluble except for group 1, strontium and barium. So calcium is not those. So calcium is going to be insoluble. Boom. That is the precipitate. Does that make sense? So this section of the worksheet, I did number 1 for you as an example. And then you just highlight the one that is going to actually be a precipitate that you will actually see in the water. Now, the next section of the worksheet is our next step in the evolution of our double replacement reactions. Okay? You see on this next part of the worksheet, the formulas are actually written all the way out. Okay? The first thing you need to do in this next part of the worksheet is balance the reaction and then circle the precipitate if there is one. So we're going to balance this first, okay? We've got 1 sodium and 1 sodium, so those look good. I've got OH here, I've got hydroxide, and oops, there's 2 OHs here, so I'm going to have to put a 2 here. And that's going to change my chlorines to 2. My sodiums to 2. So now I've got 2 sodiums, and that also gives me 2 chlorines. Well, there's 2 chlorines here. 1 calcium, 1 calcium, we're good. 2, 1, 2, 1. So we balanced it, and then it says circle the precipitate. So we will look on our rules again, and these are precipitates. Let's see. Sodium chloride, that's going to be aqueous. And then you see our hydroxides here are insoluble. So this is going to be the precipitate. Okay? So you circle the precipitate. So you're going to balance the equation. Then I want you to go through and label everybody that's aqueous. Everybody's going to be aqueous except for the precipitate. Circle the precipitate and label it as the precipitate. I hope that makes sense. That's pretty straightforward. Okay, now this last section right here is the hardest section, okay? And I'm not saying it's so hard you can't do it, but in this section, you're giving these formulas, and then now you're going to write the new formulas over here with their partners switched. So for example, in this one, the sodium was with hydroxide here, but on this side, you're going to write the sodium with the nitrate. Now what's hard about that is you have to write the correct formula every time according to their oxidation numbers. For example, this mercury right here is obviously a +1 because it's with nitrate. So when the mercury is with the hydroxide over here, you have to remember that that mercury was +1. Let me show you an example. So if you look here, you've got sodium carbonate and aluminum chloride. Both of these are aqueous. Now, if we're going to do a double replacement reaction, the sodium will now need to be with the chloride. So you'd write sodium chloride. We look that up on our tables and we see that obviously sodium chloride is soluble. So that will be aqueous. That is not going to be a precipitate. And now, aluminum will be with carbonate. So we have to remember that aluminum, when we're writing the formula for aluminum carbonate, aluminum is +3. Carbonate is -2, right? So it's going to be Al2CO3. You have to write the formula correctly or everything will be wrong. Okay, your balancing will come out wrong. Okay. Let's see if aluminum carbonate would be a precipitate. If not, we're done. Okay? All carbonates are insoluble except for group 1 and ammonium. So guess what? Aluminum carbonate, we're going to circle that. It is a precipitate. We're going to label precipitate. And now we're going to balance and finish. I've got 2 sodiums. So I would want to put a 2 here for my sodiums. But I'm looking here, I've got 3 chlorines. So that's not going to work. All right? Let's balance these carbonates out. I've got 1 carbonate here, right? But I've got 3 over here. So if I put a 3 here, that'll give me 6 sodiums. I need a 6 there. That gives me 6 chlorines. Got 3 chlorines here, so I'm going to need a 2. And look, isn't that convenient? Al2. So 3, 2, 6, 1. And this is the precipitate. So you need to be able to try that. Now, I've only given you 3 to try. I've only given you these 3 to try. So you're going to take these guys and you're going to rewrite them over here where their partners switched. Then you're going to balance them, and then you're going to circle the one that's a precipitate. If there is a precipitate. If there's not a precipitate, you could just write no reaction. And I have a really good idea that at least one of these is not going to have a precipitate. Last part of your worksheet, just think. This is about single replacement reactions and what we would do in real life if we wanted to do a single replacement reaction. So that's just think. All right, peace out, people. Peace out. Do your homework. Watch this video.